find the distance between 1, 5, and -5, 3. So, in the coordinates paper, this is our graph. So, the distance between -5 and 3, -5, 3, and 1 and 5. So, it's solved. To get the distance, our formula is equals to d is equals to the square root of x sub 2 minus x sub 1 raised to 2 plus y sub 2 minus y sub 1 raised to 2. So, in a given value coordinates, so our x sub 1 is equals to 1, then our y sub 1 is equals to 5, x sub 2 is equals to -5, and y sub 2 is equals to 3. So, let's, substitute the value of x sub 1 and x sub 2. So, our equation will be -5 minus 1, then we substitute the y sub 2 minus y sub 1. So, 3 is equals to -5. So, our equation will be distance is equals to the square root of -5 minus 1 raised to 2 plus 3 minus 5 raised to 2. So, -5 minus 1 is equals to -6. Then, 3 minus 5 is equals to -2. So, -6 raised to 2 is equals to 36. Then, -2 raised to 2 is equals to 4. So, 36 plus 4 is equals to the square root of 40. So, our distance is equals to 2, the square root of 10 units. So, distance from 5, 3 to 1, 5 is equals to 2 square root of 10 units. So, problem number 2, let's solve the distance -2, -4, and 1 and 6. So, the coordinate paper. So, this is the graph. So, let's solve the distance between this. So, our x sub 1 is equals to 2, then y sub 1 equals to 4, x sub 2, 1, then y sub 2 is equals to 6. So, let's substitute the value. So, our equation will be d is equals to 1 plus 2 raised to 2 plus 6 plus 4 raised to 2. So, 1 plus 1 is equals to 3, then 6 plus 4 is equals to 10. So, the square root of 3 is equals to 9, and the square root of 3 raised to 2 is equals to 9, and 10 raised to 2 is equals to 100. So, 9 plus 100 is equals to 109. So, the distance from -2, -4 to 1 and 6, so is equals to the square root of 109 units. So, number 3, our coordinates is -3, 4, and 3, 6. So, this is the graph. So, let's solve the distance between -3, 4 to 3, 6. So, our x sub 1 will be -3, y sub 1 is equals to 4, x sub 2 is equals to 3, then y sub 2 is equals to 6. So, our equation will be d is equals to the square root of 3 plus 3 raised to 2 plus 6 minus 4 raised to 2. So, 3 plus 3 is equals to 6. Then, 6 minus 4 is equals to 2. So, the square 6 raised to 2 is equals to 36. Then, 2 raised to 2 is equals to 4. So, 36 plus 4 is equals to 40, or 2, the square root of 10 units. So, the distance is equals to 2 raised to the square root of 10 units. So, next problem. 8, 1, and 0, -5. So, this is our graph. 8, 1, and 0, -5. So, let's solve the distance between this. So, our x sub 1 is equals to 8, y sub 1, 1, x sub 2 is equals to 0, and y sub 2 is equals to -5. Our equation will be d is equals to the square root of 0, -8 raised to 2 plus -5 minus 1 raised to 2. So, 0 minus 8 is equals to -8. -5 minus 1 is equals to -6. So, then, -8 raised to 2 is equals to 64. -6 raised to 2 is equals to 36. 64 plus 36 is equals to 100. So, the square root of 100 is equals to 10. So, our distance is equals to 10 units. So, our distance from 0, -5 to 8, 1 is equals to 10 units. Number 5, our coordinates is R1, 3 halves, and -7, -5 halves. So this is our coordinates and coordinate paper. So we solve the distance between the 2 points. So our x sub 1 will be 1, y sub 1 is also 3 half, x sub 2 is also -7, and y sub 2 is also -5 half. So our equation will be distance is equal to the square root of -7 minus 1 raised to 2 plus -5 halves minus 3 halves raised to 2. So -7 minus 1 is equal to -8. -5 halves minus 3 halves is equal to -4. So -8 raised to 2 is equal to 64. And -4 raised to 2 is equal to 16. So 64 plus 16 is equal to the square root of 80. So, or distance is equal to 4 square root of 5 units. So, the distance between these 2 points is equal to 4 the square root of 5 units. So, next problem, number 6. Point. So, -2, 3 over -3 fourth and 5, -5 12. So, this is the point, the coordinate paper. So, solve the distance from these points to this. So, our x sub 1 will be -2 third, and y sub 1 is also -3 fourth. X sub 2 is equal to 5, and y sub 2 is equal to -5 half. Our equation will be d is equals to the square root of 5 plus 2 third raised to 2 plus -5 12 plus 3 fourth. So, raised to 2. 5 plus 2 third is equal to 17 over 3. Then -5 12 plus 3 fourth is equal to 1 third. The 17 over 3 raised to 2 is equal to 289 over 9. And 1 third raised to 2 is equal to 1 over 9. So let's add 289 over 9 plus 1 over 9. So it will become 290 over 9. So the square root of 290, or our distance is equals to 1 third the square root of 290 units. So our distance is 1 third the square root of 290 units. So number 8, show that -2, 5, -2, -1, and 4, -1 all lie on a circle whose center is at 1, 2. Find the length of the radius. So to solve the radius, let's get the distance. So from 1, 2, and -2, 5. So our equation, so to get the radius, let's use the distance formula, which is d equals to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So our x sub 1 is equals to 1, and y sub 2 is equals to 2. X sub 2 is equals to -2, and y sub 2 is equals to 5. So our y sub 1 equals to 2. So let's substitute the value. So our equation will be the square root of -2 minus 1 raised to 2 plus 5 minus 2 raised to 2. So -2 minus 1 is equal to -3. Then 5 minus 2 is equal to 3. So the square root of -3 raised to 2 is equal to 9. Then 3 raised to 2 is equal to 9. So 9 plus 9 will become 18. So our distance equals to the square root of 18, or 3 the square root of 2 units. So our radius equals to 3 square root of 2 units. So number 9, show that the points 4, 5, 1, 1, and -2, 5 are the vertices of an isosceles triangle. So find the area. So isosceles triangles, two sides are equal. So this is our graph. So -2, 5, 0.45, and 0.1, 1. So this is our triangle. to solve the area of triangle, our formula is area is equal to 1 half times b times the square root of a squared minus b squared over 4. So first, let's solve the distance from 4, 5 to 1, 1. So 4, 5, so let's solve the distance here, so or the vertices. So let's use the distance formula, which is the square root of x sub 2 minus x sub 1 raised to 2 plus y sub 2 minus y sub 1 raised to 2. So our x sub 1 equals to 4, y sub 1 equals to 5, so our x sub 2 is equals to 1, then x sub 1 is equals to 1. So let's substitute the value. So our distance is equals to the square root of 1 minus 4 raised to 2 plus 1 minus 5 raised to 2. So 1 minus 4 is equals to negative 3. 1 minus 5 is equals to negative 4. Then negative 3 square raised to 2 is equals to 9. And negative 4 raised to 2 is equals to 16. So 9 plus 16 is equals to 25. So the square root of 25 is equals to 5. So our distance is equals to 5 units. So then let's solve the distance from 4, 5 and negative 2, 5. So next, let's solve this distance from negative 2, 5 and 4, 5. So let's use the distance formula again. So our x sub 1 will be 4, y sub 2 is equals to 5, y sub 1 is equals to 5, then x sub 2 is equals to negative 2, and our y sub 2 is equals to 5. So let's substitute the value. Our equation will be distance is equals to the square root of negative 2 minus 4 raised to 2 plus 5 minus 5 raised to 2. So negative 2 minus 4 is equals to negative 6, and 5 minus 5 is equals to 0. So negative 6 raised to 2 is equals to 36. The square root of 36 is equals to 6 units. So our distance is 6 units. Then last, so the distance from 1, 1 and negative 2, 5. So 1, 1 and negative 2, 5. So let's solve the distance. So our x sub 1 will be 1, y sub 1 is equals to 1, x sub 2 is equals to negative 2, and y sub 2 is equals to 5. Our distance will be equals to the square root of negative 2 minus 1 raised to 1 raised to 2 plus 5 minus 1 raised to 2. So negative 2 minus 1 is equals to 3. Then 5 minus 1 is equals to 4. Negative 3 raised to 2 is equals to 9. And negative 4 raised to 2 is equals to 16. So 9 plus 16 is equals to 25. 25, the square root of 25 is equals to 5. So our distance is equals to 5 units. So we have all the distance. So let's solve the area of triangle. So to solve our formula, area is equals to 1 half times b times the square root of a squared minus b squared over 4. So our a is equals to 5 units from the given solution. Then our b is equals to 6. So let's substitute the value. So area is equals to 1 half times 6 times the square root of 5 raised to 2 minus 6 raised to 2 over 4. So 5 raised to 2 is equals to 25. Then 6 minus 6 raised to 2 is equals to 36. So 36, our equation will be a is equals to 1 half times 6 times the square root of 25 minus 36 over 4. So 36 over 4 is equals to 9, and 25 minus 9 is equals to 16. So the square root of 16 is equals to 4. So our equation will be a is equals to 1 half times 6 times 4. So 6 times 4 is equals to 24. Then 24 divided by 2 is equals to 12. So our area is equals to 12 square units. So the area of our isosceles triangle is equals to 12 square units. So number 10, show that the points -1, -2, 2, 1, and -3, 6 are the vertices of a right triangle. So find the area. So this is our graph or our triangle and graphing paper. So let's solve the area. First, let's solve the distance from -2, -1, and -2, 1. So let's solve the distance from the point 2, 1 to the point -1, -2. So let's use the distance formula. Our x sub 1 is equal to -1, then x sub 2 is equal to -2, y sub 1 is equal to -2, then our x sub 2 is equal to 2, and our y sub 2 is equal to 1. So let's substitute the value. Our equation will be distance is equal to the square root of 2 plus 1 squared plus 1 plus 2 squared. So 2 plus 1 is equal to 3, and 1 plus 2 is equal to 3. So the 3 raised to 2 is equal to 9, and 3 raised to 2 raised to is equal to 9. So 9 plus 9 is equal to 18. So our first distance is equal to 18 units. Then let's solve the distance from point -1, -2, and -3, 6. So our equation will be d is equal to the square root of -3 plus 1 raised to 2 plus 6 plus 2 raised to 2. So our is equal to -2 plus 8. So -2 raised to 2 is equal to 4. Then 8 raised to 2 is equal to 64. So 64 plus 4 is equal to 70. So our distance is equal to 70 units. Then last, let's solve the distance from -2, 2, 1, and -3, 6. 2, 1, -3, 6. Let's solve the distance from this point to this point. So our equation will be distance is equal to the square root of -3, -2 raised to 2 plus 6 minus 1 raised to 2. So -3 minus 2 is equal to -5. Then 6 minus 1 is equals to 5. So -5 raised to 2 is equals to 25. Then 5 raised to 2 is equals to 25. So let's add 25 plus 25 is equals to 50 units. So our distance is equal to 50 the square root of 50 units. So to solve the area of the right triangle, our equation will be 1/2 times b times h. So let the given value from our solution will be the value of b, which is the square root of 50, and the height, which is the square root of 18. Let's solve the area. So let's substitute the value of b and h. Our equation will be area is equal to 1/2 times the square root of 50 times the square root of 18. So square root of 50 times square root of 18 is equals to 30. 30 divided by 2. Our equation will be a is equals to 30 over 2. So our area is equals to 15 square units. So the area of this triangle is equals to 15 square units. So number 14, find the area of a quadrilateral having the points -3, 4, and -2, -1, 4, 4, and 0, 5 as vertices. So our graph, so this is our quadrilateral. So first, to solve the area of this quadrilateral, make a triangle here to solve the area of a triangle. So our graph will become like this. So A, B, C, and D. So let's solve this. The first, this triangle ADC, which is 0, 5, -3, 4, and -2, -1. So to solve the area of triangle, our equation will be, or formula, equals to 1/2 times to x sub 1 times y sub 2 minus y sub 3 plus x sub 2 times y sub 3 minus y sub 1 plus x sub 3 times y sub 1 minus y sub 2. So our point or coordinates from the point is equals to 0, 5, negative 3, 4, and negative 2, negative 1. So our x sub 1 will is equals to 0, x sub 2 is equals to negative 3, x sub 3 is equals to negative 2, and y sub 1 is equals to 5, y sub 2 is equals to 4, and y sub 3 is equals to negative 1. So, no. Angle. So, to solve first, let's solve the area of triangle ABC. So, let's substitute the value. Our equation will be triangle ABC is equal to 1 half times 2, 0, times 4 plus 1 plus negative 3 times negative 3 minus 5 plus negative 2 times 5 minus 4. So, 0 times 4 plus 1 is equals to 0. So, negative 3, let's add this. So, combine negative 5 minus 5 is equals to negative 6. Then, 5 minus 4 is equals to 1. So, our equation will be triangle ABC is equals to is equals to 1 half times 0 plus negative 3 times negative 6 plus negative 2 times 1. So, negative 3 times negative 6 is equals to positive 18. So, negative 2 times 1 is equals to negative 2. So, 18 minus 2 is equals to 16. Then, 16 over 2 is equals to 8. So, our area of triangle ADC is equals to 8 square units. So, our area of this triangle ADC is equals to 8 units. Then, let's solve this. Let's solve the area of triangle ABC. So, our x sub 1 is equals to 0, x sub 2, 4, x sub 3 is equals to negative 2, and our y sub 1 is equals to 5, y sub 2 is equals to 4, and our y sub 3 is equals to negative 1. So, again, our formula to get the area of triangle is equals to 1 half times 2, x sub 1 times y sub 2 minus y sub 3 plus x sub 2 times y sub 3 minus y sub 1 plus x sub 3 times 2 y sub 1 minus y sub 2. So, let's substitute the value. Our equation will be triangle ABC is equals to 1 half times 2, 0, times 4 plus 1 plus 4 times 2 negative 1 minus 5 plus negative 2 times 5 minus 4. So, 0 multiply to 4 plus 1 is equals to 0. So, negative 1 minus 5 is equals to negative 6. Then, 5 minus 4 is equals to 1. So, our equation will be triangle ABC is equals to 1 half times 2, 4 times negative 6 plus negative 2 times 1. So, negative 4 times 2 negative 6 is equals to negative 24. So, negative 2 times 2 1 is equals to negative 2. Our equation will be triangle ABC is equals to 1 half times 2 26. So, 26 over 2 is equals to 13 square units. So, the area of our triangle ABC is equals to 13 square units. So, to get the area of our quadrilateral, so let's combine the two area of triangle. So, triangle ABC plus triangle ABC is equals to 8 plus 13 or 21 square units. So, the area of our quadrilateral is equals to 21 square units. So, number 17, find the radius of a circle with a center at 4, 1 if a chord of length is equals to 4 square root of 2 is bisected at 7, 4. So, the given is 4, 1 and 7, 4. So, let's use the Pythagorean theorem, which is c squared is equals to a squared plus b squared. So, let b the length of the chord over 2, then a is equals to distance. First, let's solve the distance. So, our x sub 1 is equals to 4, y sub 1 is equals to 1, x sub 2 is equals to 7, and y sub 2 is equals to 4. So, distance is equals to the square root of 7 minus 4. raised to 2 plus 4 minus 1 raised to 2. So 7 minus 4 is equals to 3, and 4 minus 1 is equals to 3. So 3 raised to 2 is equal to 9, and 3 raised to 2 is equal to 9. So 9 plus 9 is equals to 18. So distance is 18. So A is equals to distance. So our A is equals to 18. So to get A squared, squared both sides. So A raised to 2 will become A squared, and the square root of 18 raised to 2. So cancel the square root and squared. So our A squared is equals to 18. So then our B is equals to 4 square root of 2 over 2. So B is equals to 2 square root of 2. So to get B squared, squared both sides. So 2 raised to 2 is equals to 4. Then cancel the square root of 2. So B squared is equals to 4 times 2. So our B squared is equals to 8. So let's solve. We will use Pythagorean theorem. So C squared is equals to A squared plus B squared. So substitute the A squared and B squared. So 18 plus 8. So 18 plus 8 is equals to 26. Our C squared is equals to 26. So divide to get the C squared of squared the C squared and 26. So C squared will become like this. So the square root of C squared is equals to the square root of 26. So C is equals to 26, the square root of 26. So our radius is equals to 26 units. So next, 18. The radius of a circle is 5, and its center is at -3 and -4. So find the length of the chord that is bisected at -11 halves and -13 halves. So our given is -3. Our given are -3 and -4, 11 and -11 halves and -13 halves, and our radius is 5 units. Let's solve the distance. So our x sub 1 is equals to -3, y sub 1 is equals to -4, our x sub 2 is equals to -11 halves, and y sub 2 is equals to 13 halves. So our r is equals to 5. So let's substitute the value. Distance is equals to the square root of -11 halves plus 3 over raised to 2 plus -13 halves plus 4 raised to 2. So 11 halves plus 3 is equals to -5 halves, and -13 halves plus 4 equals to -5 halves. So -5 halves raised to 2 equals to 25 plus 4, and -5 halves raised to 2 is equals to 25 plus 4. So 25 over 4 plus 25 over 4 is equals to 50 over 4. So distance is equals to 50 over 4, or our A is equals to 50, the square root of 50 over 4. So let's use Pythagorean theorem again, which is C squared plus A squared plus B squared. So let's substitute. So our radius is equals to C, which is 5. Then our A is equals to 50, the square root of 50 over 4. So our equation will be 5 raised to 2 is equals to the square root of 50 over 4 raised to 2 plus B squared. So 5 raised to 2 is equals to 25. Then the square root of 50 over 4 raised to 2 is equals to 50 over 4. So our equation will be B squared is equals to 25 minus 50 over 4. So 25 minus 50 over 4 is equals to 25 over 2. So to get the B, our equation will be the square root of B squared is equals to the square root of 25 over 2. So our B is equals to the square root of 25 over 2. So let's L is equals to 2B. So, or length of the chord. So substitute the B. So 25 over the square root of 25 over 2. So times 2 will become 5 square root of 2. So the length of the chord. So the length of the chord is equals to 5 square root of 2. Number 21. Find the point on the y-axis that is equidistant from 5, 1 and negative 3, negative 1. So, the unknown is the value of y. So, our equation will be, or given, x sub 1 is equals to 0, y sub 1 is equals to y, since y is its value is unknown. Then, x sub 2 is equals to 5, y sub 2 is equals to 1, x sub 1 is equals to 0, and again, our y sub 1 is equals to y. From the right side, since it is unknown, then our x sub 2 is equals to negative 3 and y sub 2 is equals to negative 1. So this is the structure of our formula. So to get the value of y, our equation will be the square root of x sub 2 minus x sub 1 raised to 2 plus y sub 2 minus y sub 1 raised to 2 is equals to the square root of x sub 2 minus x sub 1 raised to 2 plus y sub 2 minus y sub 1 raised to 2, since we need the value of y-axis that is equidistant. Substitute the given value, so our equation will be the square root of 5 minus 0 raised to 2 plus 1 minus y raised to 2 is equals to the square root of negative 3 minus 0 raised to 2 plus negative 1 minus y raised to 2. So 5 minus 0 is equals to 5, and expand the value of 1 minus y raised to 2 is equals to 1 minus 2y plus y squared. Then negative 3 minus 0 is equals to negative 3. Then expand negative 1 minus y is equals to positive 1 plus 2y plus y squared. So 5 raised to 2 is equals to 25, and negative 3 raised to 2 is equals to 25. So squared both sides to cancel the square root. So our equation will be 25 plus 1 minus 2y plus y squared is equals to 9 plus 1 plus 2y plus y squared. So combine like terms. So 25 plus 1 is equals to 26, and 9 plus 1 is equals to 10. So our equation will be 26 minus 2y plus y squared is equals to 10 plus 2y plus y squared. So transpose the value of 2y and plus y squared from right to the left. Our equation will be negative 2y minus 2y plus y squared minus y squared. So y squared, positive y squared minus y squared cancel out, so magiging 0. Negative 2y minus 2y is equals to 4y. Then 10 minus 26 is equals to negative 16. So our equation will be negative 4y and negative 16. So divide to get the value of y, divide both sides by negative 4. So negative 16 divide negative 4 is equals to positive 4. So our y is positive 4. So the point on the y-axis that is equidistant from 5, 1 and negative 3 and negative 1 is equals to 4. So our value is 0. Ang x is equals to 0 and y is equals to 4. So this is our graph. So the equidistance. So next problem, 22. A line segment 5 units long has one of its end at 3, 1. The ordinate of the other end is 5, so find its abscissa. So the abscissa is unknown, or x is unknown. So our given is equals to d is equals to 5 units. Then its coordinates is 3, 1 and x and 5. So x is unknown, so let's find its abscissa. So x sub 1 is equals to 1, y sub 1 is equals to 5, x sub 2 will be 3, and y sub 2 is equals to 1. So let's find its value, the value of x. So our equation, d is equals to the square root of x sub 2 minus x sub 1 raised to 2 plus y sub 2 minus y sub 1 raised to 2. So substitute the given value. D is equals to 5, then our x sub 1 and x sub 2, y sub 1 and y sub 2. So 5 is equals to the square root of 3 minus x raised to 2 plus 1 minus 5 raised to 2. So expand the value of 3 minus x, it will become 9 minus 6x plus x squared. Then 1 minus 5 is equals to negative 4. So So, negative 4 raised to 2 will become 14, positive 14. So, to get the radical sign, we need to raise to 2 both sides or squared both sides. So, 5 raised to 2 will become 25. Then, cancel out the radical sign. It will become x squared minus 6x plus 16 plus 9. So, our equation will be 25 is equals to x squared minus 6x plus 16 plus 9. So, transpose the value of 9 to the, or 16 plus 9 is equals to 25. So, transpose to the left to cancel out 25. It will become 25 minus 25 is equals to x squared minus 6x. So, 25 minus 25 is equals to 0. Then, the remaining is x squared minus 6x. So, to get the value of x, factor out. So, let's factor x squared minus 6x. It will become x quantity x minus 6. So, the value of x is 2, which is 0 and positive 6. So, a line segment 5 units long has one end and 3, 1. The ordinate of the other end is 5. So, its abscissa is either 0 and 6. Problem number 24. The point x1 is 2, square root of 5 units away from 2, 3. Find x. So, our x is unknown. And our given is 0.23 and distance of 2, the square root of 5. So, our x sub 1 will be x since it is unknown. And y sub 1 is 5. X sub 2 is 2. And our y sub 1 is 3. So, so our y sub 2 is 1 rather. So, our formula is distance formula, which is d is equals to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So, distribute or substitute the value. Our d is 2 square root of 5. Then, our x sub 2 is 2 and our x sub 1 is x. Our y sub 2 is 2 and our y sub 1 is 1. So, our equation will be 2 square root of 5 is equals to the square root of 2 minus x raised to 2 plus 3 minus 1 raised to 2. So, expand 2 minus x, it will become 4 minus 4x plus x squared. So, 3 minus 1 raised to 2 is equals to 2. So, 2 raised to 2 is equals to 4. To get the radical sign, you must raise both sides to 2. So, 2 square root of 5 raised to 2 will become 4 times 5 and cancel the radical sign here. So, it will become x squared minus 4x plus 8. So, 4 times 5 will become 20. Then, transpose to the left, to 20 to the right, it will become negative 20. So, our equation will be 0 is equals to x squared minus 4x plus 8 minus 20. So, 8 minus 20, it will become negative 12. So, x squared minus 4x minus 12 is equals to 0. Equate to 0 to factor out. So, the factor of x squared minus 4x minus 12 is equals to x minus x and x plus 2. So, the value of x is 6, then negative 2. So, the point is either 6, 1 or negative 2, 1. So, next problem, number 25. What are the coordinates of a point 3 units from y-axis and at distance square root of 5 from 5, 3? So, our given is distance, which is the square root of 5, and our point 5, 3, then 3, and y. Since y is unknown, so let's find y. Our x sub 1 is equals to 5, y sub 1 is equals to 3, x sub 2 is equals to 3, and y sub 2 is equals to y. Our equation will be d is equals to the square root of x sub 2 minus x sub 1 raised to 2 plus y sub 2 minus y sub 1 raised to 2. After substituting, this is our equation is the square root of 5 is equals to the square root of 3 minus 5 raised to 2 plus y minus 3 raised to 2. So 3 minus 5 will become negative 2. Then expand y minus 3 raised to 2, it will become y squared minus 6y plus 9. So 2, negative 2 raised to 2 will become 4. So raise both sides into 2. So cancel out the radical sign. So our equation will be 5 is equals to y squared minus 6y plus 9 plus 4. So combine like terms, it will become 9 plus 4 equals to 13. Then transpose negative 5, positive 5 from left to the right, it will become negative 5. So 13 plus 5, it will become minus 5, it will become positive 8. So our equation will be y squared minus 6y plus 8. So factor out. So the factor of y squared minus 6y plus 8 is equals to y minus 4 and y minus 2. So the value of y is equals to 4 and 2. So the point is either 3, 4 or 3, 2. Number 26. A point whose abscissa and ordinate are equal is the square root of 10 units away from negative 1, negative 3. Find the point. So D is equals to 10 units. Our point is negative 1 and negative 3. So X is equals to Y. So since they are both equal, let X be the unknown. So our X sub 1 is equals to negative 1 and Y sub 1 is equal to negative 3. So our X sub 2 is equals to X, then Y sub 2 is equals to X since they are equal. So substitute the value, our equation will be the square root of 10 is equals to the square root of x plus 1 squared plus x sub 3 squared. So expand, or first let's raise both sides to 2 to cancel out the radical sign or the square root. So our equation will be 10 is equals to x plus 1 squared plus x plus 3 squared. So expand x plus 1 and x plus 3. So it will become 10 is equals to x squared plus 2x plus 1 and plus x squared plus 6x plus 9. So combine like terms. So x squared plus x squared is equals to 2x, then 6x plus 2x will become 8x. So after that, 1 plus 9 is equals to 10. So our equation will be 10 is equals to 2x squared plus x squared, 8x plus 10. So divide both sides into 2. So 10 divided by 2 is equals to 5. Then 2x divided 2 will become 2x squared divided 2 will become x squared. Then 8x will become 4x. Then 10 equals to 5. So transpose 5 from the left to the right, it will become negative 5. So combine like terms, positive 5 minus 5 will become 0. So our equation will be x squared plus 4x equals to 0. So factor out x in the equation. So it will become x times 2, x plus 4. So the value of x, or to get the factor of this equation will become x equals to 0. Then x equals to negative 4. So it's the point whose abscissa and ordinate are equal equals to is 0, 0, or its origin and negative 4, negative 4. Number 27. The ordinate of a point, which is the square root of 29 units from 5, 1, is twice its abscissa. Find the point. So distance is the square root of 29. Then our point is 5, 1. So y is equals to 2x. So our equation, other point is x and 2x. So our y sub 1 is equals to 5, then y sub 1 is equals to 1. Then our x sub 2 is equals to x, and our y sub 2 is equals to 2x, since it is twice its abscissa. So distribute the value. Our equation will be the square root of 29 is equals to the square root of x minus 5 raised to 2 plus 2x minus 1 raised to 2. So squared both sides. Oh yeah, squared both sides, or raised to 2 both sides to cancel out the radical sign or square root. So it will become 29 is equals to x minus 5 raised to 2 plus 2x minus 1 raised to 2. So expand x minus 5 will become x squared minus 10x plus 25. Then expand to x minus 1 raised to 2 will become 4x squared minus 4x plus 1. So combine like terms, our equation will be 29 is equals to 5x squared minus 14x plus 26. So transpose 29 from the left to the right, so it will become negative 29. Our equation will be 0 is equals to 5x squared minus 14x plus 26 minus 29. So 26 minus 29 will become negative 3. So factor out, or factor 5x squared minus 14x minus 3 to get the value of x. So the factor is equals to x minus 3 and 5x plus 1. So the value of x is 3 and value of x is negative 1 over 5. So to get the value of y, let's substitute the value of x. So y is equals to 2x and it is twice the x. So let's substitute the value first of 3. So y is equals to 2 times 3 will become y is equals to 6. Then substitute the negative 1 over 5. So y is equals to 2x. Then y is equals to 2 times 2 negative 1 5 will become y is equals to negative 2 fifths. So our answer is either 0.3 and 6 and negative 1 5 negative 2 fifths. So number 28. The abscissa of a point is 2 fifths of its ordinate. Find the point if it is 5 units away from negative 2, positive 2. So our distance is 5 units. Our ordinate is, or our point is negative 2, positive 2. So x is 2 fifths of y, since abscissa of a point is 2 fifths of its ordinate. So our other point is 2 fifths y and y. So our x sub 1 is equals to 2. Then our y sub 1 is equals to negative 2. So our x sub 2 is equals to 2 fifths y. Then y squared is equals to y. So substitute the value. Our equation will become 5 is equals to the square root of 2 fifths y minus 2 raised to 2 plus y minus 2 raised to 2. So raised to 2 both sides, or squared both sides to cancel out the radical sign. Our equation will be, so squared 5 will become 25. 5 times 5, 25. So then 2 fifths y minus 2 raised to 2 plus y minus 2 raised to 2. So expand. Our equation will be 25 is equals to 4 over 25 y squared plus 8 over 5 y plus 4 plus y squared minus 4y plus 4. So combine like terms. Our equation will be 25 is equals to 29 over 25 y squared minus 12 over 5 y plus 8. So transpose 25 from the left to the right, it will become negative 25. So 0 is equals to 29 over 25 y squared minus 12 over 5 y plus 8 minus 25. So 8 minus 25 will become negative 17. So factor to get the value of y. So the factor and the value of y is equals to negative 8 over 29 and y is equals to 5. So to get the value of x, let's substitute the value of y. So since x is equals to 2 fifths of y, so substitute the value of 2 of y. So first let's substitute the first value of y, which is negative 85 over 29. So 8 is equals to 2 fifths times 2 negative 85 over 29. So x is equals to negative 34 over 29. Then next, let's substitute the value of y, which is 5. So x is equals to 2 fifths times 5, so x is equals to 2. So the points, since our point is, so if it's ordinate, so find the point if it's 5 units away. So the point are negative 34 over 29 and negative 85/29. So and positive 5. So number 29, the abscissa and ordinate of a point to square root of 5 units from 3, positive 3 are numerically equal, not but of opposite signs. So find the point. Our given, the given is, or r, d is distance equals to square root of 5. So our point, so the point is 3, 3. So since x is equals to y, but of opposite sign, so x is equals to negative y, or x is equals to negative x, since equal, it is equal. So the other point is x and negative x. So our x sub 1 is equals to x, then y sub 1 is equals to negative x. So our x sub 2 is equals to 3 and y sub 2 is equals to 3. So substitute the value. Our equation will be, substitute the value to the distance formula. So our equation will be 2 square root of 5 is equals to the square root of 3 minus x squared plus 3 plus x raised to 2. So squared both sides to cancel out the radical sign. It will become 4 times 5 is equals to 3 minus x squared plus 3 plus x raised to 2. So expand, it will become 20 is equals to 9 minus 6x plus x squared plus 9 plus 6x plus x squared. So then combine like terms, our equation will become 20 is equals to 2x squared plus 18. So transpose positive 20 to from left to the right, it will become negative 20. So or transpose 18 from the right to the left, it will become negative 18. So 20 minus 18 is equals to 2x squared. So 20 minus 18 is equals to 2. So 2x squared is equals to 2. So to get the value of x, divide both sides into 2. So it will become x squared is equals to 1. So square then square, get the value of x. So square root of x squared will become x, then square root of 1 is equals to 1. So our x is equals to 1. So to get y, substitute the value of x. So y is equals to negative x. So y, substitute the value of x to give the, which is 1. So y is equals to negative 1. So y, our answer is 1 and negative 1, or negative 1 positive 1. So number 30, the abscissa of a point in the fourth quadrant is numerically 3 times its ordinate and is 10 units from negative 2, 4. Find the point. So distance is 10 units, then our point is negative 2, 4. So x in fourth quadrant and 3y. So the answer must be positive x and negative y, since it is in fourth quadrant. So find x. So our x sub 1 is negative 2 and y sub 1 is equals to 4. Our x sub 2 is equals to 3y, then our y sub 2 is equals to negative y. So substitute the value in the distance formula. So our equation will be 10 is equals to the square root of 3y plus 2 raised to 2 plus minus y minus 4. So raised to 2, then get the square root of, or raise both sides into 2. Our equation will be x 100 is equals to 3y plus 2 raised to 2 plus minus y minus 4 raised to 2. So expand 3y plus 2 will become 9y squared plus 12y plus 4. Then expand negative y minus 4, it will become positive y squared plus 8y plus 16. So combine like terms, our equation will be 100 is equals to 10y squared plus 20y plus 20. So divide both sides by 10. it will become 10 is equals to y squared plus 2y plus 2. So, transpose positive 10 from the right to the left, it will become negative 10. So, our equation will be 0 is equals to y squared plus 2y plus 2 minus 10. So, positive 2 minus 10, it will become negative 8. So, y squared plus 2y minus 8. So, factor y squared plus 2y minus 8, it will become y minus 4, quantity of y minus 4 and quantity of y plus 2. So, the value of y is 4 and negative 2. So, to get x, we will substitute the value of y. Since the x is in the fourth quadrant, so the y is negative. So, we will use y is equals to negative 2. So, since x is equals to negative 3y, substitute the value of negative 2. So, x is equals to 3 times 2 negative 2. So, it will become negative 6. So, since the x is in fourth quadrant, so it is positive. So, the value of x is positive 6 since it is in the fourth quadrant. So, our answer is 6, positive 6 and negative 2. So, 31. Expressed by an algebraic equation the statement that the point xy is equidistant from 6, negative 2 and 5, positive 2. So, our equation will be 6, negative 2. Our point is 6, negative 2, 5, 2, and xy. So, we will use this formula or equation, which is the square root of x minus x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared is equals to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So, from the left equation, our x sub 1 is equals to positive 6. Then, our y sub 1 is equals to negative 2. Our x sub 2 is equals to x. And our y sub 2 is equals to y. So, from the right equation, our x sub 1 is 5. Y sub 2 is equals to 2. X sub 2 is equals to x. Then, y sub 2 is equals to y. So, substitute the value to the given equation. Our equation will be the square root of x minus 5 raised to 2 plus y minus 2 raised to 2 is equals to the square root of x minus 6 raised to 2 plus y plus 2 raised to 2. So, squared both sides to get the value, to get the radical sign or the square root. Our equation will be x minus 5 raised to 2 plus y minus 2 raised to 2 is equal to x minus 6 raised to 2 plus y plus 2 raised to 2. So, expand will become x minus 10x plus 25 plus y squared minus 4y plus 4 is equals to x squared minus 12x plus 36 plus y squared plus 4y plus 4. So, combine like terms, then transform. So, x plus y squared, x squared plus y squared minus 10x minus 4y plus 25 plus 4 is equals to x squared plus y squared minus 12x plus 4y plus 36 plus 4. So, cancel out x squared plus y squared plus 4 and x squared plus y squared plus 4. Since we combine, it will cancel out. So, it will become 0. Our equation will be negative 10x minus 4y plus 25 is equals to negative 12 plus 4y plus 36. So, transpose negative 12y and positive 4y from the right to the left, it will become negative 20x plus 12x minus 4y minus 4 is equals to 36 and minus 25. So, transpose this 25 to from the left to the right, it will become negative 25. So, combine negative 10x plus 12x will become positive 2x and negative 4y minus 4y will become negative 8y. Then 36 minus 25 is equals to 11. So, our answer is 2x minus 8y is equals to 11. So, 32. Expressed by an algebraic equation, the statement that the point xy is at a distance 3 from 7, negative 7, negative 3. So, our point is negative 7, negative 3. And x y. So our distance is 3 units. So our x sub 1 is negative 7, then y sub 1 is negative 3. So our x sub 2 is equals to x, then y sub 2 is equals to y. Substitute the value, so our equation will be 3 is equals to the square root of x plus 7 raised to 2 plus y plus 3 raised to 2. So squared both sides to get the radical sign. So 3 raised to 2 will become 9. Then x plus 7 raised to 2 plus y plus 3 raised to 2. So expand, x plus 7 raised to 2 will become x squared plus 14x plus 49. Then expand y plus 3 raised to 2. So y squared plus 6y plus 9. So combine like terms, then transpose positive 9 from the left to the right will become negative 9. So x squared plus 14x plus 49 plus y squared plus 6 plus 9 minus 9. So 9 minus positive 9 minus 9 will become 0. So x squared plus y squared plus 14x plus 6y plus 49 is the answer. So the algebraic equation of the statement.